Beneath the geysers and hot springs and bison-dotted meadows of Yellowstone National Park lies one of the most powerful geological features on the planet, a supervolcano, a vast reservoir of molten and partially molten rock feeding a caldera so large it can only be fully appreciated from space. For generations, Yellowstone has captured the imagination as a sleeping giant, the subject of countless dramatic scenarios about what would happen if it ever truly awoke. And there is a real and fascinating science behind those imaginings, because Yellowstone has, in its distant geological past, produced eruptions of almost incomprehensible scale. The question that draws so much fascination is a natural one: if Yellowstone were to erupt in a great supereruption, which places would be affected first and most severely? Which cities would stand in the path of the most immediate devastation? This is the story of that scenario, of the 7 cities and regions that would face the earliest and gravest consequences of a Yellowstone supereruption, but it is also, and more importantly, a story about what the science actually says, about how such an event would really unfold, and about why the reality is at once more nuanced and less apocalyptic than the popular imagination often assumes. Before we go a single step further, there is something that must be said clearly and emphatically, because responsible discussion of this topic demands it above all else. Yellowstone is not about to erupt. There is no sign of an impending supereruption, no evidence that catastrophe is near, and the scientists who monitor the volcano around the clock consider a great caldera-forming eruption to be extraordinarily unlikely in any human time frame. The idea that Yellowstone is somehow overdue is a myth, a misunderstanding of how volcanoes work, because these events do not operate on a fixed schedule and cannot be predicted from past intervals. The most probable hazards at Yellowstone are far smaller events, and a supereruption, while possible on the vast timescale of geology, is among the least likely things to happen there in our lifetimes or those of many generations to come. This is not a warning that disaster looms. It is an exploration of a fascinating what-if, grounded in real science, undertaken with the clear understanding that the scenario described is remote in the extreme. With that essential context firmly established, we can explore what a Yellowstone supereruption would actually mean, and which places would face its earliest fury. Understanding the sleeping giant to understand what would happen if Yellowstone erupted, you first have to understand what Yellowstone actually is, because it is unlike the volcanoes most people picture. When we imagine a volcano, we typically think of a cone-shaped mountain like Mount Fuji or Mount St. Helens, a peak that rises above the landscape and erupts from its summit. Yellowstone is nothing like that. It is a caldera volcano, and its defining feature is not a mountain but a vast depression in the ground, a caldera dozens of miles across, formed when previous enormous eruptions emptied the magma chamber below and caused the overlying ground to collapse inward. Beneath this caldera lies an immense system of partially molten rock, a magma reservoir of staggering size, heated by a plume of hot material rising from deep within the earth. This is the engine that powers Yellowstone's famous geysers and hot springs, the geothermal wonderland that draws millions of visitors, and it is the same engine that, in the distant past, has produced eruptions of extraordinary magnitude. The reason Yellowstone earns the label supervolcano is the scale of its greatest past eruptions. Over the past couple of million years, Yellowstone has produced several truly colossal caldera forming eruptions, events so large that they dwarf anything witnessed in recorded human history. These eruptions ejected enormous volumes of material, blanketed vast regions in ash, and reshaped the landscape across a large part of the continent. It is these rare cataclysmic events that give rise to the apocalyptic scenarios, and they are real, they genuinely happened long ago. But it is crucial to understand that these great eruptions are extraordinarily rare, separated by hundreds of thousands of years, and that Yellowstone has also produced many smaller eruptions and events in between, and has spent the overwhelming majority of its existence quiet. The supervolcano is real, its past power is real, but the frequency of its greatest eruptions is measured in geological ages, not human lifetimes, and this is the essential context for everything that follows. What a supereruption would actually do if Yellowstone were to produce a full-scale supereruption, the rare cataclysmic kind, what would actually happen, And how would the devastation be distributed across the landscape? Understanding the physical reality of such an event is the key to understanding which places would be affected first and most severely. And it reveals a picture more complex than the notion of a single blast wiping out everything at once. The devastation of a supereruption would come in distinct forms, each with its own reach, and the danger to any given place would depend on its distance from the caldera and its position relative to the winds, closest to the eruption. Within a radius of perhaps 100 kilometers or so from the caldera, the most extreme and immediate destruction would occur. Here, the eruption would unleash pyroclastic flows, fast-moving avalanches of superheated gas, ash, and volcanic rock that race across the landscape at tremendous speed, incinerating and burying everything in their path. These flows are among the most lethal of all volcanic phenomena, and within their reach, destruction would be near total and survival nearly impossible. They move too fast to outrun and are far too hot to endure, sweeping across valleys and over ridges with a force that levels and buries whatever stands before them. It is this innermost zone, close to the caldera, where the phrase "vanish first" would be most literally true, for here the landscape itself would be remade and everything upon it erased. This is the zone of immediate obliteration, the area closest to the caldera where the raw violence of the eruption would be most concentrated. Beyond this innermost zone, the dominant threat would shift to something different but still devastating: ashfall. The eruption would blast an enormous column of volcanic ash high into the atmosphere, and that ash would then rain down across an immense area, carried by the prevailing winds. The thickness of the ash would diminish with distance from the caldera, so that places relatively near would be buried under many feet of it, while places farther away would receive lesser but still significant accumulations. This ashfall is what would give a Yellowstone supereruption its continental reach, spreading its effects across a vast swath of the country and beyond, far outside the zone of the pyroclastic flows. It is worth pausing to understand why volcanic ash is so dangerous, because it is the mechanism by which a supereruption would affect the greatest number of people and places. Volcanic ash is not like the soft ash from a wood fire. It is made of tiny, sharp particles of pulverized rock and glass, abrasive and heavy, especially when it becomes wet. Accumulating on rooftops, it can grow heavy enough to collapse buildings. It can clog and destroy machinery, foul water supplies, ruin crops, and make the air hazardous to breathe, damaging the lungs of anyone exposed. It can bring transportation to a halt, grounding aircraft, blocking roads, and disabling vehicles. Even a relatively modest accumulation of ash can cripple a modern city, and a heavy accumulation can render a region uninhabitable for an extended time. This is why the reach of the ash, spreading far beyond the immediate blast zone, is what would make a supereruption a catastrophe of continental scale, and why the cities most affected would be determined not only by proximity, but by which way the wind was blowing. The two kinds of vulnerable cities, with this understanding of how a supereruption's devastation would be distributed, we can see that the cities most affected would fall into two broad categories, and this distinction is essential to understanding which places would truly face the gravest and earliest consequences. The first category is proximity, the cities and communities closest to the caldera. Within or near the zone where pyroclastic flows and the heaviest ashfall would strike, facing the most immediate and total destruction regardless of the wind. The second category is downwind exposure, the larger, more distant cities that, while beyond the reach of the pyroclastic flows, would lie in the path of the ash carried by the prevailing winds, and would be buried and crippled under heavy ashfall. Which specific distant cities would suffer most would depend heavily on the wind direction at the time of the eruption, since the ash plume would be carried in whatever direction the winds were blowing. In general, the prevailing winds across this region tend to blow toward the east and southeast, meaning that, in a typical scenario, the heaviest downwind ashfall would tend to spread across the interior of the continent in that direction. But winds vary, and a different pattern at the time of an eruption would redistribute the ash accordingly. With this framework, proximity on one hand, downwind exposure on the other, we can identify the 7 cities and regions that would stand at the front of the line. the places that would face the earliest and gravest consequences of a Yellowstone supereruption. It is worth remembering throughout that these are illustrative of the pattern of danger, not precise predictions, and that the entire scenario remains, as emphasized, extraordinarily unlikely. The first cities, the communities closest to the caldera at the very front of the line, stand the small communities that sit closest to Yellowstone itself, nestled in the mountains and valleys immediately around the park, and their inclusion is a matter of simple, brutal geography. Towns like the gateway communities that ring the park, the small cities and towns just outside its boundaries, along with the mountain communities of the surrounding region, sit within or near the zone that would face the most immediate and extreme effects of a supereruption. These are the places closest to the caldera, and in the scenario of a great eruption, they would be within reach of the pyroclastic flows and the very heaviest ashfall, facing near total destruction with little chance of anything surviving in the immediate vicinity. These communities are small, home to relatively few people compared to the great cities farther away, but they occupy the most dangerous ground of all, the innermost zone where the eruption's raw violence would be concentrated. The gateway towns that serve as entrances to the park, the small resort communities of the surrounding mountains, the scattered settlements of the high country immediately around Yellowstone, these would be the first to vanish, obliterated by the pyroclastic flows and buried under the deepest ash, simply because they are the closest. Their story is a reminder that in a volcanic catastrophe, proximity is destiny, and the places nearest the caldera face the gravest danger, regardless of their size. These small communities, living amid the beauty of the Yellowstone region, occupy ground that is spectacular precisely because of the volcanic forces beneath it, and in the rare event of a supereruption, that same volcanic power would make their location the most perilous on the continent. The regional cities within reach, moving outward from the immediate vicinity of the park. The next cities in the path are the regional population centers of the surrounding states, the small and mid-sized cities of the northern Rocky Mountain region that lie close enough to the caldera to face severe consequences from a supereruption. These are the cities that anchor the region around Yellowstone, the hubs of the sparsely populated Intermountain West, and their proximity places them among the earliest and most severely affected in the scenario of a great eruption. Consider the cities of the region to the north and west of the park, in the valleys of the northern Rockies, communities that serve as regional centers for agriculture, education, and commerce across a wide rural expanse. These cities lie close enough to Yellowstone that in a supereruption they would face heavy ashfall and, depending on their exact distance and the eruption's dynamics, potentially the outer reaches of the most severe effects. They would be buried under deep accumulations of ash, their infrastructure crippled, their buildings threatened with collapse under the weight, their populations forced to flee or shelter in extraordinarily hazardous conditions. Consider, too, the cities to the south, and the valleys and plains below the park, regional centers of their own areas, which would similarly face heavy ashfall and severe disruption owing to their proximity. And consider the cities to the east, on the plains beyond the mountains, which sit in the direction that the prevailing winds often blow, and would therefore be doubly exposed, both by their relative closeness and by their downwind position. These regional cities, larger than the gateway towns, but still modest by national standards, would bear an enormous share of the catastrophe, close enough to the caldera to suffer among the most severe effects short of the immediate obliteration zone. And their inclusion reflects the harsh reality that the entire region surrounding Yellowstone would be transformed by a great eruption. The distant giants downwind the final cities in the path are the ones that surprise people most, because they are not small mountain towns, but major metropolitan areas, large cities far from Yellowstone that would nonetheless face serious consequences from a supereruption owing to the vast reach of the ash. These are the distant giants. The large population centers of the broader interior West that, while well beyond the zone of pyroclastic flows and immediate destruction, would lie within the enormous footprint of the ash plume and would be buried and disrupted by significant ashfall carried to them on the winds. A large city to the south of Yellowstone, a major metropolitan center of the Intermountain region, would in many wind scenarios receive substantial ashfall, enough to cripple its infrastructure, threaten its buildings, foul its water, ground its transportation, and endanger the health of its large population, though far from the caldera and safe from the flows. Such a city would face a catastrophe of its own kind, its millions of residents confronting the paralyzing effects of a heavy blanket of volcanic ash. And a major city farther still, out on the plains to the east and south, one of the great population centers of the region, could likewise receive meaningful ashfall in the scenarios where the winds carried the plume in its direction. Its enormous population facing disruption on a massive scale, even at a great distance from the volcano. These distant giants would not vanish in the way the closest communities would. They would not be obliterated by pyroclastic flows. But they would be severely affected, their normal functioning shattered by the ash, and because they are home to so many people. The human scale of their disruption would be immense. Their inclusion in the list reflects the crucial truth that a Yellowstone supereruption would not be a merely local event, but one whose reach would extend across a large part of the continent, touching cities hundreds of miles away and affecting millions of people who might imagine themselves safely distant from the volcano. Why the wind would decide so much, one of the most important and least understood aspects of the entire scenario, is the enormous role that wind would play in determining which distant cities suffered most, and it deserves special emphasis because it reveals how much of the outcome would depend on the conditions at the precise moment of an eruption. The pyroclastic flows and the most immediate destruction would strike the area around the caldera regardless of the wind, but the ash, the mechanism by which the eruption would reach the distant cities, would be carried entirely at the mercy of the atmospheric winds at the time. This means that the fate of the distant cities is not fixed, but conditional. In a scenario where the winds blew toward the east and southeast, as they often do in this region, the great plume of ash would spread across the interior of the continent in that direction, burying the cities and plains to the east and southeast under the heaviest downwind accumulations. In a scenario with different winds, the ash would go elsewhere, sparing some cities and burdening others. The same eruption, occurring on 2 different days with 2 different weather patterns, could produce dramatically different maps of which distant cities suffered most. This is why any list of the cities that would be affected must be understood as illustrative rather than definitive, a depiction of the general pattern of danger rather than a precise prediction. Because the specific distribution of the ashfall would be decided by the winds of the moment. It is a humbling reminder of how much, in such an event, would come down to chance, to the direction the wind happened to be blowing on the day the improbable occurred, and it underscores why the cities closest to the caldera are the most certain to be affected. Since their danger comes from proximity and the flows, which do not depend on the wind, while the danger to the distant giants hangs on the fickle question of atmospheric conditions. The continental and global reach. Beyond the 7 cities and the regions immediately affected, a full Yellowstone supereruption would produce consequences that would ripple across the entire continent and around the world, and understanding this wider reach is essential to grasping the true scale of what such an event would mean. The ashfall, while heaviest near the caldera and along the downwind path, would spread in diminishing quantities across a vast portion of the country, dusting cities and farmlands far from the volcano and disrupting life across an enormous area. The great agricultural heartland of the continent, some of the most productive farmland on Earth, lies within the potential reach of significant ashfall. And the burial of croplands under ash could deal a severe blow to food production, with consequences rippling through the food supply far beyond the region directly affected. The interior West is also crisscrossed by the infrastructure that binds the continent together: the highways, the railroads, the power lines, the pipelines. The flight corridors that carry people and goods and energy across the country, and a heavy blanket of ash across this region would sever many of these arteries at once, isolating communities, halting commerce, and complicating any response for a vast area. The disruption would not respect the boundaries of the ashfall itself, because a modern economy is deeply interconnected. And the paralysis of one great region would send shocks through the systems that the entire nation depends upon. In this way, even people and places far outside the reach of any ash would feel the consequences of a great eruption through the disruption of the transportation, energy, and food systems that tie the whole country together into a single web. And the effects would not stop at the ashfall. A supereruption of the greatest magnitude would inject enormous quantities of gas and fine particles high into the atmosphere, into the stratosphere, where they would spread around the globe and reflect sunlight back into space. This could produce a measurable cooling of the global climate for a period of time, a phenomenon known from other great volcanic eruptions in history, which have caused temporary drops in global temperatures and disrupted weather patterns and harvests around the world. In the most extreme scenarios, such cooling could affect growing seasons and agriculture across the planet, turning a North American catastrophe into a global one, with impacts on food and climate felt far from the volcano itself. This global dimension is part of what makes the supereruption scenario so dramatic in the popular imagination, and it is grounded in real science. Great eruptions genuinely can affect the global climate. But here again, perspective and proportion matter enormously. And it is essential to weigh this alongside the overriding reality of how unlikely such an event is, which we must now return to and emphasize once more. The truth about the odds, having explored the dramatic scenario of a supereruption and its effects, it is absolutely essential to return, firmly and at length, to the reality of the odds. Because without this context, the entire discussion risks leaving a false and harmful impression. The single most important fact about a Yellowstone supereruption is how extraordinarily unlikely it is, and this fact must be held at the center of any honest treatment of the subject. The great caldera forming eruptions of Yellowstone's past were separated by hundreds of thousands of years, and there is no scientific basis whatsoever for believing that another is imminent or even likely in any time frame relevant to human beings alive today, or for many generations to come. The notion that Yellowstone is overdue for an eruption is simply false, a persistent myth that reflects a fundamental misunderstanding of how volcanoes behave. Volcanoes do not erupt on regular schedules like clockwork, and the intervals between past eruptions do not predict when the next will occur. The idea of being overdue applies to things that happen at regular intervals. And supervolcanic eruptions are not such things. They occur irregularly, driven by complex processes deep within the Earth, and cannot be forecast from the mere passage of time since the last event. Moreover, scientists who study Yellowstone closely have found no evidence that the volcano is building toward a great eruption. The magma reservoir beneath it, while large, is not thought to contain the necessary quantity of eruptible molten rock in the right conditions to produce a supereruption at present. And the volcano's current behavior, its earthquakes, its ground movements, its geothermal activity, is entirely consistent with an ordinary, quiet, non-erupting supervolcano going about its normal existence. In short, everything that is actually known about Yellowstone points away from an imminent catastrophe, not toward one. It is also worth emphasizing that even when Yellowstone does eventually become active again, which it may on some distant timescale, the most likely event is not a supereruption at all, but something far smaller. The overwhelming majority of Yellowstone's volcanic history consists of smaller eruptions and events, and the most probable future activity would similarly be on a much smaller scale, a lava flow, a modest eruption, or most likely of all, a hydrothermal explosion, a steam-driven blast that, while locally hazardous, would be nothing remotely like the continental catastrophe of a supereruption. The Great Caldera forming event is the rarest and least likely of all the things Yellowstone might eventually do. So while the supereruption scenario is real, fascinating, and worth understanding, it must always be placed in its proper context, as an extraordinarily rare event, not imminent, not overdue, not predictable from the past, and far less likely than the smaller events that would themselves be uncommon. The sleeping giant is sleeping soundly, and there is no reason to believe it is about to wake. The watchful eyes on the volcano part of what allows scientists to speak with such confidence about the absence of any imminent threat is the intensive, continuous monitoring that Yellowstone receives. A scientific vigil that watches the volcano around the clock and would detect the signs of any significant change long before an eruption could occur. Yellowstone is one of the most closely monitored volcanic systems in the world, studied by a dedicated observatory and a network of instruments that track its every tremor and shift. Seismometers record the constant small earthquakes that occur beneath the park, part of its normal behavior and would detect any unusual increase or pattern that might signal magma on the move. Instruments measure the subtle rising and falling of the ground, the breathing of the caldera as pressures shift beneath it, movements that are watched carefully for any sign of concern. The temperature and chemistry of the geothermal features, the emissions of volcanic gases, and many other indicators are all monitored continuously. The reassuring truth is that a supereruption would not happen without warning. Such an event would require the movement and accumulation of enormous quantities of magma, a process that would produce unmistakable and prolonged signals, intense and escalating earthquake activity, dramatic deformation of the ground, major changes in the geothermal system. Signals that would build over a significant period of time, likely weeks, months, or even years, before any eruption. The monitoring network is designed precisely to detect such signals, and scientists are confident that they would see a great eruption coming well in advance, giving time for warning and response. This continuous vigilance is a source of genuine reassurance, a reminder that the volcano is not an unwatched menace, but a well-understood natural system kept under careful and constant observation. The people who monitor Yellowstone are not alarmed, and their calm, grounded in the data they gather every day, is the most authoritative answer to the anxieties that the supereruption scenario can provoke. The giant is watched over, and it is quiet. Why we are drawn to the scenario there is something worth reflecting on in the enduring fascination that the Yellowstone supereruption holds over the public imagination, because it reveals as much about human psychology as about geology. The scenario of a supervolcano destroying cities and altering the climate of the planet is undeniably dramatic, tapping into a deep human fascination with catastrophe, with the forces of nature that dwarf human power, with the fragility of our civilization in the face of the Earth's immense energies. There is a kind of awe in contemplating a force so vast that it could reshape a continent, an awe that draws us to imagine the scenario again and again in documentaries and articles and conversations, even though the event itself is among the least likely of catastrophes to actually befall us. This fascination is not harmful in itself, and indeed it can be a doorway to genuine scientific understanding, to an appreciation of the remarkable geology of Yellowstone and the powerful forces at work beneath our feet. But it becomes a problem when the drama overwhelms the reality, when the vivid image of catastrophe crowds out the far more important and reassuring truth about how unlikely that catastrophe is. The responsible way to engage with the Yellowstone scenario is to hold both things at once, to appreciate the genuine power and fascination of the supervolcano, to understand honestly what a great eruption would do, and at the very same time to keep firmly in view the overwhelming reality that such an eruption is not imminent, not overdue, and extraordinarily unlikely in any time frame that need concern us. The awe and the reassurance are not in conflict. They are two parts of a complete and honest understanding. Yellowstone is genuinely one of the most powerful geological features on the planet, and it is also, right now and for the foreseeable future, a sleeping giant that shows no sign of waking. Both of these things are true, and holding them together is the key to thinking clearly about the sleeping supervolcano beneath the geysers. The real lesson of Yellowstone in the end, the story of what would happen if Yellowstone erupted, and of the 7 cities and regions that would face its earliest fury, is valuable not as a prophecy of doom, but as a window into the extraordinary forces that shape our planet and the ways in which human civilization exists in relationship with them. The scenario teaches us about pyroclastic flows and ashfall, about the reach of a great eruption and the role of the winds, about the way proximity and atmospheric chance would together determine the distribution of a catastrophe. It teaches us to appreciate the immense power sleeping beneath a landscape of surpassing beauty and to respect the geological forces that have shaped the continent over millions of years. And it teaches us, perhaps most importantly, about the difference between fascination and fear, between understanding a hazard and being consumed by dread of it. The 7 cities that would vanish or suffer first in a Yellowstone supereruption, the small communities closest to the caldera, the regional centers within reach, and the distant giants downwind, stand as illustrations of how such an event would unfold, of the pattern of danger radiating outward from the volcano and carried on the winds. But they stand equally as reminders that this event is not coming, that the volcano beneath them sleeps soundly and is watched over carefully, and that the people who live in the beautiful country around Yellowstone do so in far greater safety than the dramatic scenarios might suggest. The real lesson of Yellowstone is one of perspective, that we can hold in our minds the genuine grandeur and power of the supervolcano, can understand honestly what it is capable of, and can at the same time live without fear in the knowledge that its great eruptions belong to the vast rhythms of geological time, not to the span of our own lives. The giant sleeps, the scientists keep their steady watch, and the geysers play on above the magma below, in a landscape where the awesome power of the earth is on display every day in forms of beauty rather than destruction. That is the true and lasting image of Yellowstone, not a doomsday clock ticking down towards some inevitable catastrophe, but a magnificent and remarkably well understood natural wonder, powerful